Ask the Experts has been going for some months. So this is our 6th meeting. And they seem to be becoming increasingly popular, which is excellent. We're very lucky this evening to have Hugo Spowers speaking about his revolutionary hydrogen fuel cell 2-seater vehicle called Riversimple. This is causing all sorts of ripples amongst the COP26 organising committee. I gather that the UK Research Institute has selected this Riversimple as one of only 2 enterprises that they want to promote at COP26. So we are very lucky to have Hugo speaking to us tonight, because I know he's in great demand and doesn't often give talks. So Marlow Energy Group are doing well to get him. Dave Hampton was the link. So I'd like to thank Dave for putting me in touch with Hugo Spowers. And so without further ado, I'm going to hand over to Susanna Nicklin, who will be telling you about MEG, for those that don't know.
So tonight is, as we know, with Hugo Spowers of Riversimple. We'll be really excited to hear him talk about the hydrogen cars. Marlow Energy Group is a group that has been going for a few years now, and has been designed really to help Marlow make the transition to a carbon neutral and a green town. It's a not-for-profit community benefit society. We have worked with a number of the other local groups to really extend the power of what we can do. We are a membership organization, and so we would love more people to participate and become members and take part. You can move ahead, Sean. Yeah, the objectives of the group are, first off, to help Marlow become a net zero carbon town sooner rather than later. We also have a lot of incredible expertise within the group already, but also really leveraging networks to facilitate knowledge exchange, effective networking and collaboration across all angles, really, of this energy transition and revolution. We also are keen to work with local organizations and businesses and homeowners to develop and invest in renewable energy schemes, from solar to hydro and beyond, potentially. We also want to help support local community share ownership. This is a model that has been very successful in other parts of the country, and we would like to see it come to Marlow on a larger scale and create opportunities for local businesses and people to benefit from local generation of power and other renewable projects. So actually, this is our 6th Ask the Expert, but the next will be our 7th, and we're not quite sure, I think, what the topic of that is. But if you'd like to be on our mailing list, please get in touch on the website that's up there, www.marlowenergygroup.com. We would love you to join. It's only £10 to join, and you can find all the information about how to do that on the website. So we do need volunteers. We need people with all kinds of skills. So if after tonight you'd like to learn more, and if you'd like to sign up, please go ahead and do that. And we hope to welcome you and engage more broadly across a diverse mix of people across Marlow. So thank you very much for joining tonight.
Thank you, Susanna. So next up is Dave Hampton. So Dave, of course, is the link with Hugo. He was also Marlow's carbon coach. I don't know if he still does carbon coaching, but he certainly is an expert. If you want to know what your carbon footprint is, talk to Dave. So Dave, over to you.
No, great to hear what you said, Susanna. I'm very delighted to be a fully paid up member of Marlow Energy Group. And yeah, as Robin said, been round the block a few times, but not in a Riversimple yet. My job tonight is just to introduce Hugo, who is a very good friend. Hugo was the founder and chief engineer of Riversimple, which is a UK company. It is headquartered in Wales, although Hugo himself, unlike the script you got before the meeting, is English as it happens, but I'm sure he would be very proud to be Welsh, covering all bases. Hugo's an Oxford University trained engineer and entrepreneur, and his first business was in motorsport, designing and building racing cars, would you believe, and also restoring historic racing cars. But he left motorsport, I'm sure, with a broken heart for environmental reasons in 2001, and set up something called Oscar Automotive. 2001 was actually the same year that I first met Hugo at Schumacher College in Totnes, which is an amazing place, those of you that know it. It was a business and sustainability week led by some of the finest and most amazing individuals and thought leaders you will ever imagine. So Oscar then became Riversimple in 2007. And just to say briefly, Hugo's core belief is that step change in automotive technology is both essential and possible. Everyone knows it's essential, but I think Hugo is demonstrating the art of the possible. He's responsible not just for the technical aspects of the car, but also the architecture of the business itself. So it's not just the car that's radically reinvented. The ownership model and the governance structure are both radically different from anything you've ever seen, not just in the automotive industry, but across the business world. He's considered as something of a thought leader, and don't worry, I'm winding up soon, something of a thought leader on the circular economy, and has been invited to give many talks on entrepreneurship at Imperial College London and Cranfield University, amongst others. So here's the best bit. At the Real Innovation Awards in October 2019, hosted by the London Business School, Hugo was awarded, wait for it, the George Bernard Shaw Unreasonable Person Award. Such an award does exist. And the citation was for someone who has shown enormous tenacity and stubbornness in pursuing an idea, despite the difficulties encountered along the way. So with that, I will leave you to the stubborn tenaciousness and the hands of the one and only Hugo Spowers. Over to you, Hugo.
Right, Hugo, before you start, can I just remind people that if they have questions, they put them in the chat, which on most computers is the middle of the bottom of the screen. If we have enough time at the end, we'll take questions from everybody here if they have any then. Sorry, Hugo, off you go.
And that's fine, John, and thank you very much, Dave, for dragging up various little bits and pieces, morsels like that. I will try and go through quite a sort of rich diet of different aspects of Riversimple as quickly as possible. Do it within 30 minutes, and if we can hold questions till after, as John says, that would be great. And look forward to lively discussion thereafter. I'm just going to share my screen now, and hopefully can you all see that?
Yes.
So Riversimple I set up, as Dave and Robin have said, for reasons of sustainability. I left motor racing for environmental reasons. And we are a sustainable car company, not a hydrogen car company. We are building hydrogen cars, but the reason we're building hydrogen cars is not because we're hydrogen enthusiasts, but because we don't believe that anything can be remotely as efficient as a hydrogen car for the sort of range to which we've become accustomed. And it's absolutely not a battle between hydrogen and batteries. We don't, after all, argue about whether it's going to be solar PV or wind turbines that win the renewable energy race. They're different, and we need them both. And it's really rather a silly question. And I think the same is true of batteries and hydrogen. They're both very, very different technologies, and we need them for different roles. But longer range vehicles, or vehicles with high utilization, where they haven't got a lot of downtime, hydrogen works much better. I now can't advance my slides. There we go. So Riversimple is set up with this purpose, and the purpose is not just a fluffy PR line. It is actually embedded in our Articles of Association as the primary fiduciary responsibility of the board. It's to pursue systematically the elimination of the environmental impact of personal transport. And it's quite an ambitious goal, but I think there are two key words to highlight. One is the elimination, which is the ambitious bit, because being less unsustainable is still not sustainable. So goal of reduction is not an adequate goal, but we're not going to get there overnight. We recognize the ambition. And so the other key word is systematically. It'll take a long time, but we've got to make sure that every step we take, every investment we make is taking us towards that end goal rather than down some blind alley. It's all too easy to invest in something that is less damaging. But if it's only going to be a little bit less damaging, but never has any hope of being sustainable, it's actually a sunk investment that you're going to have to write off because you reach a dead end. You can't get to where you want to go, a totally sustainable system. And you've got to write off all the investment you made in getting to the wrong place and start all over again. So the whole business is developed on a backcasting principle rather than a forecasting principle. We're not trying to think where we are now, how can we be a little bit better? We're imagining a point far in the future where we've got a sustainable transport system, and our strategy is developed backwards from that to work out how it is that we got there. And that way you end up with a totally different strategy and you avoid any of the pitfalls of investing in interim solutions. I'm sorry, there we go. So this is a quick trajectory of the vehicles we've done. I'm not going to talk much about the technology. I wouldn't say it's necessarily the easy bit, but it's certainly easier than the other bit. The real barriers aren't technical. They're all to do with people and politics and inertia in our business systems. The engineering work, there's a lot to do and there's a lot we have done, but it's relatively predictable stuff now. With these vehicles, we've been through the bits to prove that the showstoppers are soluble. And right at the back there's an eco marathon car that we did that was doing on about the equivalent of about 8,000 miles to the gallon but on hydrogen. We never developed it very far. It was done with students at Oxford University, and it was while we were working on getting grant funding to build the Morgan Life car, the second car, which is the first real car that we built. It never ran on its own wheels. It only ran in a test cell at Cranfield, but it did prove that what we were saying was technically possible. It had a fuel cell of only 22 kilowatts, that's about 30 horsepower. It could do, in the test cell, 0 to 60 in 7 seconds, and it did the equivalent of 178 miles to the gallon. And we'll come back to this, but one of the real barriers we had in winkling money out of the government was the fact that we were saying we were using existing available off-the-shelf technology, which was not quite true, but nearly. And they weren't funding anything that was patentable. There was no new widget, no new material. We were just putting everything together in a different pattern of relationships. And they said, well, if we're nothing that's patentable, why are we funding it? And you think, well, maybe a 4-fold improvement in energy efficiency is of interest, a 300% improvement. But that without anything patentable, that falls on stony ground. And then the third car was the first car we built, not to go on public roads, but it was a car that we could drive around. You could sit in the car. It was smaller than a Smart. It had the same sort of luggage space as a Smart. And it demonstrated that you could package all the technology in a small car. And then finally, 2 generations of the Rasa, which is the first car we've designed and built for type approval for use on the public roads. This is the prototype Rasa that's been running for 4 years now. And as you can see, it does 0 to 60 in 9.5 seconds. It has a fuel consumption equivalent to 250 miles to the gallon. which even if we use hydrogen from natural gas, which is where 90% of the world's hydrogen comes from at the moment, it's still only 40 grams per kilometre well to wheel. It's 0 grams car that's on the market today, any combustion engine car on the market today, because the figures that we hear are only tailpipe figures, they're not well to wheel. And the advantage we have as a startup is that we have a clean sheet of paper. This is why it's called rasa, as in tabula rasa. We are able to design a car around the characteristics of hydrogen rather than try and shoehorn the technology into the sort of cars that we've been making for the last 100 years. We don't have any of the exit barriers of an existing company. And by designing around the characteristics of hydrogen from a clean sheet of paper, it lowers the cost, dramatically lowers the stress on the new technologies, supercapacitors and fuel cells in particular, and it leads to at least a threefold improvement in energy efficiency. So I can contrast this with the Toyota Mirai, which is there in the top right hand corner. Now that is a truly brilliant bit of engineering, and I don't want to suggest anything other than that. But Toyota, I know, and this is some years out of date, have spent north of 8 billion in developing their hydrogen technology, which is rather more than we've spent. And that car, we're not pretending either, it's an equivalent to our car. It's a 4-seater, not a 2-seater. But it has a fuel cell, and it has the same acceleration of 0 to 60 in 9.5 seconds. But it uses a fuel cell that's over 13 times as powerful as ours. And it uses over 3 times as much hydrogen per mile. And although it's a bigger car and has a higher top speed, it really shouldn't the difference shouldn't be quite so stark. So that is an illustration of the benefit of starting from a clean sheet of paper. But as I said, the barriers and the problems are really not principally technical. They are to do with business models. And this is really a generic illustration of the situation that every company, every country is going through. We're in the converging funnel of the two walls essentially being environmental impacts and resource depletion, climate change, those sort of environmental constraints that we haven't had to deal with in the past, and the regulations that are coming in response as a damage limitation exercise, if you like, to those constraints. And businesses that developed over the last 100, 200 years are bumping along the walls of this funnel. It's painful and it's expensive to stay within those constraints. And this is not surprising because the profit motive lies way outside the funnel. If you make cars, if you sell cars, you make more money by selling more cars. And so you're rewarded directly for maximizing resource consumption. And this leads to all sorts of problems like resource depletion, commodity price spikes as a result of that. And whilst I quite understand why the industry cannot change, it's much harder to change a business model than a technology. It's not very good business because it's betting your future profits against these known trends. We can argue about when the peaks of various when various resource peaks will hit us, whether it's oil or copper or whatever. What we can't argue about is the direction of that trend. These are natural capital resources that are being consumed, and there is no way that anybody can argue other than the fact that they are going to run out eventually, so and become more scarce. And in a world with increasing population, increasing affluence, and increased technological ability to consume resources, it is an accelerating funnel. And so this is why I think that we need to change business model. I don't see how we can ever have a sustainable industrial society based on rewarding industry for the opposite of what we're trying to achieve. It's simply never going to work. So I come back to business model, and an illustration, slightly tongue-in-cheek, of just how misaligned the business model of the industry is today. These two cars were built by the same company 70 years apart. Now, the car on the left, when it came out, did 38 miles to the gallon. The car on the right, after 70 years, did 38.6 miles to the gallon. And you've got to remember that less than halfway through that period in 1973 was the oil crisis. So one might reasonably expect a little bit more progress than that. But the honest truth and the sad truth is that if you sell cars, there is no incentive to improve efficiency. Actually, we argue there's a disincentive. And the reason for that is it does cost more to make a car more efficient. But customers will never pay a premium for a more efficient car. They always discount future cost savings almost to zero. So if you can't sell it at a premium and it costs you more to make, it reduces margin. And therein lies the disincentive. And the only thing then left to improve efficiency is regulation. But because the efficiency reduces profit margins, the industry can quite understandably and logically only lobby against those regulations. And then when eventually they do come into and delay them, but when eventually they do come into force, they cheat. And this is exactly what we've seen recently. So I think the biggest change we need to see is not one of technology, batteries or hydrogen. The biggest change we need to see is that we need to make efficiency profitable. And if we did that, we'd see a rash of cars tomorrow doing 100 miles to the gallon. So we are, as a company, we're probably the only car company who hope never to sell a car. We're only ever going to sell a service. Mobility is a service as it's become known. And this goes back to the days when I met Dave at Schumacher, even sort of 2 years before, actually, the first time I went to Schumacher, talking about selling service rather than selling product. And it completely changes the drivers as a business. In the conventional business model, this is optimistically what a manufacturer sees from each car. About 40% of the revenue maximum. It's probably more like 35%, and it's declining. Of the revenue generated by a car, including its initial sale, goes to the manufacturer. The other 60% plus goes to other people, and there's nothing the industry can do about it. If you sell the service, this is what we see. We are not leasing the car. It's important to make a distinction between leasing, which is a mechanism to keep cars moving out of the factory gates when demand goes a bit soft. So when there's an economic slump, you always see a rash of 0% finance deals to persuade people to keep on buying cars. And in our instance, though, at the end of a 3-year contract, which is typically the sort of contract we envisage, the car will come back to us. We won't sell it into the second-hand trade. We'll provide a second, third, fourth-hand customer. And critically, the two features of this, and I believe they're the two central features not talked about much, which really underpin a truly circular business model, are one, that the car has to stay on the same balance sheet from the clean sheet of paper when you design it right through to end of life. And secondly, all the operating costs must be internalized on that same P&L. And that completely changes the drivers of the manufacturer. But furthermore, 100% of the revenue that is generated by the car comes through us. For the customer, this is the only transaction they have in having the usership of a car, and all their costs of motoring are entirely predictable. So they pay a monthly direct debit, a fixed price, has a fixed price element, and it has a mileage rate like the usage rate on a mobile phone. And so if you're going to do 10,000 miles in a year, you know exactly what your motoring will cost you. And this is true even if you're the fourth-hand user of a 10-year-old car. If you take a contract for one of our cars, rather than the risk of a component failure that a normal second-hand car buyer faces, you will know exactly what your motoring is going to cost you. So it's much more convenient, it's lower risk, and it means that our drivers, instead of obsolescence and high running costs, and I say high running costs because the average markup on spare parts is about 1,500% from an OEM, an original equipment manufacturer. And instead, our drivers are longevity and low running costs, and that includes efficiency. So it changes our drivers from resource consumption, if you like, to resource conservation. And the fewer cars we have to make in order to service a certain number of customers, the more profitable we are, the cheaper it is to customers. This is looking at it from our point of view, and it has a huge impact on bringing new low carbon technologies to market. If you sell cars, and it doesn't matter whether it's a battery car or a hydrogen car, if you're going to compete with combustion engine cars, which are truly staggeringly cheap today, I think nothing beats them for value for money. Unfortunately, they're no longer fit for purpose. But if you're going to compete with them, with a new technology car, you've got to get the supply chain costs down to match those of petrol engines. And to get the supply chain costs down, you've got to get the volume up. But to get the volume up, you've got to get the supply chain costs down. And so that is a real chicken and egg problem. However, if you sell the service, the pricing to the customer is not driven by the build cost to the car. It is driven by the lifetime cost to the car. That includes the build cost, but it also includes all the operating costs and end of life. And the end of life is regarded by the industry under European legislation as approximately a €200 liability per car. We know when we're designing the car that is the business model we're designing for. So we design for maximum recovery of value, and that's not just raw materials, but components that can be refurbished and reused again. Much higher value recovered that way. We also design it to minimize the operating costs. So that is the maintenance, but also, as I pointed out, the fuel. We're paying for it, the fuel, for the life of the car. So it's in our interest to make the car efficient, even to invest more heavily in the original design of the car. But also, because we are building revenue generating assets for our balance sheet rather than products to sell, we want the life to be as long as possible because we want to lengthen that revenue stream. And those three things, the longer revenue stream, lower operating costs, and higher and value recovery at end of life, can all offset the higher build cost. So even if the car is much more expensive to build, we can compete at the same price to the customer long before our supply chain costs can match those of petrol engines. And that's one of the key barriers to the uptake of battery electric or hydrogen vehicles, is the premium the customer faces in the marketplace. But we're also moving this model upstream into the supply chain. So I'll quickly look at just one component in the car. This is the fuel cell. This is made for forklifts for Walmart warehouses in the States. It's 8.5 kilowatts, which is not quite enough electricity to power 3 domestic kettles, but it is enough to keep our car moving at 60 miles an hour. Inside it are all these membranes. It's called a fuel cell stack. You can see all that stack of plates, and each one of those has a membrane inside. And those are made by a small number of companies who specialize in the membranes and sell them to the fuel cell manufacturer. Johnson Matthey and Swindon are a major supplier of membranes. On those membranes, there's very finely divided platinum, which is the catalyst that catalyzes the reaction. All these things all sit in the car, which is in the customer's hands. But we don't want to buy the fuel cell. The customer is paying us. They don't buy the car. They pay us on a monthly base, the fixed price per month and the mileage rate. We don't buy the fuel cell, but we want to pay the fuel cell manufacturer a certain amount for having the inventory in our hands per month. We want to pay per hour that the fuel cell is running, because that degrades the fuel cell. And we also want to pay an element of the contract based on the efficiency with which the hydrogen is converted into electricity. Furthermore, we don't want the fuel cell company to buy the membrane, but to lease it off the membrane company and pay on exactly the same 3 metrics. And then the membrane company, rather than buying the platinum can lease the platinum. And ultimately, if a mining company were to lease platinum to the membrane company and recover it at the end of life, they gradually decouple their revenue stream from virgin material. In other words, ultimately, I mean, it sounds very grandiose to say so, but ultimately the logical conclusion of this is that the mining company will stop mining for good commercial reasons, because they've got enough platinum going round and round in circulation, and that's where their revenue comes from. So this is completely changes the drivers for all our suppliers. It brings our drivers into alignment with theirs. If we buy components off a supplier, we want as cheap a price as possible with as long a life as possible. They want the highest price possible with the shortest life possible, so they can sell us another one. And that's not a very good basis for a working relationship. By moving to buying the service, we align our interests, which is a much better basis for a collaborative relationship, and it allows us to have an open book policy working with suppliers on what is the best way of keeping the customers moving whilst minimizing the consumption of energy and resources. The last strategy I want to talk about really is about infrastructure, because people always ask the chicken and egg question of who's going to put in the infrastructure before the cars, and who's going to put in the cars before the infrastructure. And I think this is the way they have spent a lot of money on developing some fantastic cars, but they don't have a solution to the infrastructure. Toyota have spent all that money, and it's a wonderful car. It can travel long distance on motorways in great comfort at high speed, but they need 300 filling stations in the UK in order to create a credible market before anybody's going to buy the cars. And they're saying that poor little us at Toyota, we can't afford that, so governments, you've got to pay. And that isn't a strategy, it's just passing the buck. It's worth pointing out that all disruptive technologies, when they're immature, when they first come to market, they all have weaknesses, and they never come to market in the mainstream segment. They find a niche where the weakness doesn't matter. And then the technology develops quite quickly because it's immature, and it will develop much more quickly on the basis of a revenue stream rather than speculative investment. And when it does so, it moves upstream into the mainstream segments. The key weakness for hydrogen cars is infrastructure. And so that's why we're building a car for local use. If you build a car for local use, and there's over 3 million vehicles in the UK that never go beyond a 25-mile radius, it means that we can come to market with a critical scale of infrastructure of not of 300 filling stations, but just one. Now, it's a small market, but it's highly concentrated. So if we put 100 cars into the market, that filling station has 100 captive customers from day one. Whereas if you put 100 Toyotas into the market with 300 filling stations, they'll hardly ever see a customer. And we also work with other, not just with councils, but other vehicle providers like buses, because there are other vehicles that are also locally tethered and can build volume demand for to build a strong business case for investment in the infrastructure. And that way you can scale your infrastructure one filling station at a time, opening up one more pocket of market. Each time there's a standalone business case that makes sense, and it doesn't require a speculative leap. It allows you to develop the skeleton of a nationwide network without ever taking a nationwide gamble. And at scale, hydrogen infrastructure is much cheaper per car than battery electric charging infrastructure. The crossover, according to Ulick University, did a study on this a couple of years ago, is somewhere between 100,000 and 1 million cars. And we've got 35 million cars or so in the UK. So at that scale, it's an awful lot cheaper, because one pump, rather like a petrol pump, can support thousands of cars, unlike a battery charging point. We are building a fleet of 20 cars that are going in, COVID permitting, hopefully in April. It keeps on being put back, but and we've put in a filling station in Abergavenny, and that we will run this fleet, trial fleet, through until we're in production, which we're hoping will be in early 2024. Quick thing about production, because there are sustainability aspects to the manufacturing strategy as well. Car plants are huge, and it's a 10-year gamble if you to put up a new car plant. If you're a major manufacturer, that's the sort of lead time, because a car plant makes about 300,000 cars, and it's a huge infrastructural burden. It's a massive planning exercise and training and recruitment and so on. And in our case, we're using the same logic as the industry uses, but with steel cars, a press steel tool spits out about 300,000 cars, and that's why plants are so big. You have to assemble that many on site. The tooling costs about £1 billion, but it does produce an awful lot of cars. If you're making cars out of composite materials, as we are, the maximum throughput through one set of tooling is about 5,000 cars. It is about 100-fold lower. It's also about 100-fold cheaper. So the economics are similar. But when we expand, we need to more sets of tooling. There's no economic advantage, though, in putting them in the same place. So we don't need to knock down a small plant and build a bigger one. We just build more small plants. And this allows us to build a much more distributed manufacturing system with small pockets of 200 jobs generated by each plant. And that allows for a much more distributed and much more resilient economy. And as we're based in mid-Wales, this is close to our hearts, because 85% of Wales lives on the south coast, and they've all migrated down there in the last 200 years, first because of coal mining and then because of heavy industry. And consequently, in mid-Wales, there is a complete dearth of non-seasonal employment opportunities beyond agriculture. And consequently, any student who leaves school at 18 with decent A levels tends to leave mid-Wales and go elsewhere, and it has knock-on consequences for the whole community. So what we want to be doing is building small plants in less populated areas to bring people back to their roots, and to try and develop the fabric, help develop the fabric of strong and resilient local economies. Finally, there are 3 levels of design we talk about. We've talked about the car, the technology, that's the level of design of the product. Then design at the level of systems, which is talked about much more these days, and is epitomized by the fact that there's an emergence in the last 25 years of service design companies. But there's also a third level of designers that some designers are now talking about, which is design at the level of ideology or purpose, which is for us sustainability, and it's really manifested in the design of our governance model. So we are absolutely a for-profit business, but we regard business as a living, breathing entity. It's not a thing that people can own, and there's a lot of critical stakeholders upon whom the company depends and who are affected by the activities of the business. And so we have what are called 6 custodian companies. These hold the 6 voting shares in the company, and they represent the investors, the environment, the staff, the customers, our commercial partners, suppliers and infrastructure providers, and also the community, those bodies who have no direct commercial relationship with the company. Now, that doesn't mean in any way that the profits of the company are split between those 6 stakeholder groups. The money flows in the same sort of directions, but the control of the company is in the hands of those 6 stakeholder groups. And effectively, we've decoupled equity and control. And we believe that by doing so, we can generate a greater level of goodwill from 5 of those stakeholder groups than we ever could if their interests are subordinated to the 6. And we depend for the success of the business on the goodwill of those 6 stakeholder groups. So by doing this, we believe, and many of our investors have joined us, not because they're interested in cars, but because they're interested in the governance model. We believe that this will build a more profitable and, above all, a more resilient business. This business could never get into a deep water horizon or Dieselgate scenario. So it's a manifestation of the alignment of interests, which is really, I think, the single thread that runs through all our business strategies. We try to align interests in every relationship we build. So we align our interests as a manufacturer with those of our customer and of the suppliers, as I've pointed out, but also in alignment with the environment and regulators who are regulating to try and reduce environmental impact. We are turning all the costs of sustainability, which are a cost for businesses designed to make profit and as a primary fiduciary responsibility. We're turning those costs into a source of competitive advantage. We don't think that sustainability is in any way necessarily at odds with profitability, and we're designing a business that turns those costs into a source of competitive advantage. The last thing I'd just like to say, because it comes up a lot and it's slightly counterintuitive, is that we're often asked, aren't you trying to change too many things at once? And we argue very clearly that we would have no hope of doing all this if we just focused on the car and sold it in a conventional way. We believe very strongly that changing multiple things simultaneously when you're going through a step change it reduces risks and reduces barriers. And I'd argue that we're going through step changes in two respects. One, internally, if you like, in the technology that we're working with. It's a step change from combustion engines. That's why we have to build the car differently. But we're also going through a step change in the external conditions within which business operates. And it's those external conditions that forge business models. And businesses of the last 2 centuries were not reacting to climate change and resource depletion because they were not of any consequence in those at that time. And natural capital was regarded as infinite, which is understandable because we were but a pinprick on the sides of the planet. But now they are the biggest challenges we face. And it's much easier to design a business model to suit the challenges of the 21st century than try and tweak a business model that's designed to do something fundamentally different. When you put all this together, it does look like a lot of changes. And whenever a new idea comes along, all the reasons why it can't be done are the lightning rod of conversation. And I sort of accept that, generally speaking, all these reasons why it can't be done are true. But they assume that the new idea is going to replace an old idea, and it's going to replace the old idea in the context in which the old idea existed. And the old idea co-evolved a pattern of relationships, all sorts of relationships with other actors, and those relationships are the reasons why the new idea won't work. A new context around the new idea, a new pattern of relationships, suddenly the new idea can look an awful lot more appealing. And that's the clearest explanation I can give as to why we believe that, not always, but in the times we face at the moment, changing everything simultaneously reduces risks and reduces barriers. So I'll leave it there and be very happy to take any questions. Thank you very much.
Well, that was amazing, Hugo. I mean, there were so many new ideas, I could hardly write them all down, flying out so fast. But could I just, I mean, this is obviously an example of circular economy in action in business, presumably.
Yes.
So if you were running BP, if your name was Bernard Looney, would you be a bit worried about trying to change BP from a fossil fuel dependent company to a green company, because you're going to have to go through a step change where you gradually ramp up renewable energy? They bought a big wind farm, you know, today, where you gradually wind down your fossil fuel activities. I mean, is that a feasible model, or are they going to get seen off by all the new kids on the block who are just going to concentrate on renewables?
It's a contentious area we step into here, Robin. I think that probably it is more challenging for the auto industry than for the energy companies. I think the energy companies who see themselves as energy companies rather than oil companies, I can quite see that it is more possible to make the migration. The trouble is that as companies become more and more mature, industries become more mature, margins come down, commodity industries they become, it is very, very difficult to focus your resources on something that the customer isn't asking for. And customers aren't asking for reduced environmental impact, with a small percentage of the population accepted, of course. And they're asking for cheap motoring and often fast motoring and things like that. And even company executives, chief executives who know what's going on, find it very difficult or impossible to turn a company around to focus on something else, because a lot of informal networks, informal feedback loops in the company that keep them focused on what their customers are paying for. And they're very, very effective. And if they're not there, those companies aren't the market leaders. The market leaders are very good at being focused on customers' demands. And the energy industry, the oil industry, is unusual in that it is less, I argue, less technology specific and has got much higher profit margins. And I can quite see that how they can migrate. I do hope they do. I think it's easier for them to migrate than from the auto industry, who I think have got real challenges ahead of them. But nonetheless, BP's recent statements and about how green they're going, you have to look at what a small proportion of the spend is going on renewables and what a large proportion is still going on exploration for further reserves. And it makes you think that it hasn't really truly been internalised.
I think, well, I think it's been internalised more with them than the other oil companies. I am impressed. There's a few people who I'd just like to introduce briefly. Baroness Walmsley, you're the deputy leader of the Lib Dems in the House of Lords. Would you like to make any comment on what Hugo said?
Hugo, I'm absolutely fascinated by what you have to say. I've got a feeling I heard you speak in the House of Commons a couple of years ago. Was that right, on the terrace?
Yes, absolutely. Yes.
I very distinctly remember your very different business model. I'm on the Science and Technology Committee in the House of Lords, and we're just beginning a report about the science and technology of moving to zero carbon. So we've been talking quite a lot about hydrogen, and you're quite right about blue hydrogen. It's still a fossil fuel using energy carrier. How long do you think it'll be before your cars are able to run on hydrolyzed hydrogen?
Well, there's quite a lot of green hydrogen emerging now. I think there's two things I'd say about that. What the first is that there is a move to tie hydrogen cars and hydrogen transport and use of hydrogen to only being green hydrogen. And I absolutely and wholeheartedly support green hydrogen as the only form of hydrogen in the long term. But we're not so good at developing our transition strategies, and tying all uses of hydrogen to all sources being green hobbles the development of both the sources of hydrogen and the penetration of the hydrogen solutions. And we don't, after all, insist you can't have a battery electric car unless it's green electricity. I don't think it's useful. And in fact, I was saying that our car is only 40 grams per kilometre if it uses brown hydrogen from natural gas, grey as it's now known, from natural gas. I actually argue that in the near term, it's probably the best way to do it, because actually the natural gas is considered our cleanest form of fossil generated electricity. And let's try and get our our grid decarbonized and displace carbon that way, rather than using with electricity, any green electricity, rather than, and use the natural gas to develop hydrogen for cars, so that you don't displace the green electricity. If we use green electricity to displace petrol, it's not the best way of decarbonizing. And even if we use hydrogen from natural gas, we still are a 60% reduction on anything on the market today. The other thing is that green hydrogen doesn't necessarily only come from electricity. We can get it from biogas. And making biogas into hydrogen is much more efficient than making electricity from biogas. We can also make it from the sun directly, cracking water, photocatalytic cracking of water, concentrating solar energy with a catalyst, rather than going through a PV stage. Now, we probably won't do a lot of that in the UK, but globally, I think it'll be a major source of hydrogen. And so it is not the fact that all green hydrogen has to use green electricity, because that is quite a complicated energy path, and you have a lot of losses.
Isn't that what they're doing in Australia, where I think they're making a lot of hydrogen and methane, I think, as well,
Yes,
in Australia.
but they are making it from electricity, I think.
Are they? Oh, right. Okay.
They're not, yes. And the big project that's on the go with Japan is making it from brown coal, I'm afraid.
Robin, can I ask a couple of questions from the chat?
I looked at the chat. There weren't any questions on when I last looked. Are there now?
Yeah, the first one is from Peter Flood. It says, once the beta testing is finished, might the production RASA's components, such as the fuel cell, be specifically designed and manufactured?
Will they be specifically designed and manufactured for us, for the car?
Don't know, let me mute Peter and he can tell you. Peter?
Hello, yes, hello, good evening.
Good evening. Can you explain what you
yeah,
meant?
I hope so. It was partly obviated by Mr. Spowers' kind description of the fuel cell process, and I hope therefore it's not completely redundant now. But I do recall on a visit to the RASA's works in Wales that the point was made the fuel cells were commendably off the peg and were limited in the sense that being generic and off the peg, they were easily sourced, didn't involve any special investment, and one can totally understand the reasons. I was left as a kind of an enthusiast and a total amateur, wondering if in the production model, one might reach a little further and possibly be more ambitious with the generative power of those fuel cells.
Yes. So the core bit, the actual stack of all those membranes would be exactly the same. What's called the balancer plant, all the bits outside, blowers, pumps, humidifiers, things like that, will be slightly different. Without getting technical about it, we'd actually end up with a slightly bigger stack than anybody else would think we'd need for 10 kilowatts, but we'd run it at only half power. And that way we'd get, if we run it at half power, we'll get about 16–17% improvement in efficiency. And because of our business model, we can justify investing in twice the size of stack, which is almost twice the cost, because we've got a 17% improvement in the energy efficiency for the life of the car. It's a good example of where it completely changes your design choices at the design stage for good commercial reasons in favor of efficiency.
Can I just say,
technology won't change.
Can I just say a word about green hydrogen? Because I think it's quite important. I mean, making hydrogen by electrolysis is incredibly fuel energy demanding. I mean, it requires a huge amount of energy to split water into hydrogen. But of course, as our renewable component ramps up nationwide, we're going to have a lot of spare capacity, renewable capacity at night. For example, if you've got large wind farms, you have huge amounts of spare energy at night. and you also have a lot of spare solar energy during sunny days in the summer. So that spare capacity can be used to split hydrogen or nitrogen into ammonia. In that way, you're using hydrogen or ammonia as an energy store. It's a wonderful way of storing energy. So when you get spare renewable capacity, it changes the whole paradigm.
Okay, Hugo, another question for you from...
Can you go answer that first, please?
Oh, sorry.
I'm sharing this, John.
I'm completely with you, Robin, about curtailed sources. I'm not arguing for no electricity being used. I just wouldn't want us to lean on the grid as our primary source of hydrogen for the entire transport fleet, whilst we've still got such a long way to go with decarbonising. And I have to say that as an environmentalist and looking at truly sustainable solutions, renewable solutions, there is a lot of support for hydrogen from the nuclear industry, because it is their meal ticket. They're not very good at modulating supply, and they are involved with some of the activities in lobbying for the hydrogen economy, because I suspect that when the hydrogen economy is really accepted as being an inevitability and a requirement for sustainability, which I believe it is, the nuclear industry are going to step in and say, we're the only people who can deliver the quantities you want. So I'm very keen on finding non-electrical sources of hydrogen for multiple reasons. I don't believe we need the nuclear supply. There are very few things that we can't do 4 times as efficiently. And if we have an energy conscious society and use energy conscious technologies, I'm quite clear that renewable sources can support our demands without any loss of quality of living.
Okay. Is Jim Platt still with us or not? Jim, are you here? Jim owns the garage in Marlow, and when I arrived in Marlow, I was horrified to find he sold leaded petrol. I spent 10 years of my life trying to get lead out of petrol, so I arrived and found there was a leaded petrol pump at the beginning of my road. My ambition, of course, is that will be replaced soon by a hydrogen pump, but Jim isn't here to sort of tell us how soon he's prepared to do that. So was there another question, John, that you wanted?
Yes, it's a question from George Lawrence. What is it about fuel cells that makes them more applicable to the new business model than batteries?
That's a very good question. I'm sorry I didn't touch upon that. I absolutely believe that we need battery cars. I think they're really good news, and I'm so glad. I mean, I don't agree much with what Elon Musk says, but I'm very glad that he has really moved the dial on that and got battery cars into the market. But there's a sleight of hand played, and this is why we need both. There's a sleight of hand played that you will never beat the powertrain efficiency of a battery electric car. It's sort of 75 or 80% efficient. And that's absolutely true. A fuel cell car will never be above about 45% efficient. However, I'm not interested in the powertrain efficiency. I'm interested in the vehicle efficiency. And vehicle efficiency depends also on the weight of the car. And batteries are very heavy. So we can make a very efficient battery vehicle for short range, but as you design it for longer and longer range, you need more batteries, the car gets very heavy, and so it becomes a very inefficient vehicle. And this is where hydrogen has the role to play. Even though the powertrain efficiency of the hydrogen car is lower, only 45% of the energy you put into the car gets to the wheels. The fact is, because it's so much lighter, it needs much less energy at the wheels. And we believe that the crossover is at about 150 miles, where we can make a more efficient hydrogen car than a battery car. And an important point also about that this leads on to is that range and utilization, because of downtime for charging, are the 2 key variables that should dictate whether we use batteries in a vehicle or hydrogen. Note that it is nothing to do with size or weight. There is recently, everybody has started talking about how we need hydrogen for HGVs. And I think it's the right conclusion. But I think by and large, the way it's spoken about, the right conclusion has been reached for entirely the wrong reasons. People think we need hydrogen for HGVs because they're big. It's nothing to do with that at all. We can build a battery electric HGV that does 50 miles a day without any problem at all. But for the sort of range that a long haul HGV needs, you'd need 8 or 9 tons of batteries. I haven't done those calculations. This is what I hear from people who have. And that's why we need hydrogen, because you can't afford to carry 8 or 9 tons of batteries. And we wouldn't have a planet left if all the HGVs had 8 or 9 tons of lithium and cobalt on board. And so that wrong logic of size and weight is being applied to all sorts of other segments and reaching the wrong conclusions elsewhere. It's worth pointing out that forklifts are the only mature use of hydrogen fuel cells to date in warehouses. And forklifts are not big. It's nothing to do with size or weight. It's to do with utilization and productivity. And the same logic of utilization and range applies to everything from a forklift right up to an HGV. And cars in the middle, we absolutely need batteries for short range applications. It really, really makes sense. But we don't want to misapply the fundamentally good technology to the wrong sort of cars. And I don't believe that Tesla is the right sort of application.
So could I just ask you then, I mean, hydrogen is the ideal fuel for shipping then, isn't it? Long term. I think
hydrogen is. Hydrogen is, yes, absolutely. But I think that shipping is a hybrid. That I'm not a shipping expert, but I mean, it seems clear to me that a hybrid solution with computer-controlled kites, for instance, can dramatically reduce the amount of onboard energy required. And there's all that technology also to flow bubbles on the surface of the ship. It dramatically reduces the hydrodynamic losses if you aerate the surface of the hull. All sorts of things like this, just to reduce the energy demand. Reduce the demand before you decide how you're going to find the energy you need to fill the remaining gap.
Yeah. Okay, that's very interesting. Well, Hugo, that's been absolutely fascinating insight into the circular economy and what you're up to in Wales. I'm going to come and visit your factory. You're talking at Windsor next week, and I've given you the title, A Better ULEV Than Tesla. Is that okay with you?
I'd probably rather than promoting our product, I'd probably be keener to talk about how it's not just the technology, it's business models. Making sustainability profitable, I think, is what I think is the key thing that we've got to focus on that doesn't get enough airtime.
That's brilliant. Well, thank you ever so much. And thank you, everybody, for contributing. John, is there anything else to say?
There's a couple more questions. Have we got a couple of minutes to do them?
Are you okay for that, Hugo?
I'm fine. Okay,
absolutely. Very good.
Yeah, Alan Corcoran says, how can groups like MEG and me help promote, distribute RASA as a product stroke service?
Well, we are we're limited at the moment to the number that we can churn out. They're all hand built and constrained by manpower and finances and so on, and they're at the moment going into the trial. But we are very keen soon to start working with identifying and working with communities as to where our launch locations should be. We've recently started inviting people to register interest, and where the focus of interest is will be where we go. We've also got to work with infrastructure providers and get them on the same page, but ultimately I believe the infrastructure providers will also go where the demand is. So okay. It's local communities really demonstrating that there's an appetite, which will focus our attention on where we go. We would be looking to, in 2024, start production of cars and vans. The vans will start within 6 months of the cars, and we'll be looking probably at something like 10 different locations around the UK where we'd roll out initially.
Okay, and I think the last question, Robin, if that's all right. Tony Cowling says, one day we will be able to make hydrogen directly from sunlight. How far off is that panacea?
Well, it's done. It's been done for quite a while in the lab. It isn't done at an industrial scale yet. And I don't know the answer to when. I don't really, honestly don't know the barriers to it being done at scale. But it certainly can be done. And it seems to me to be, it has got to be a more efficient in terms of energy out for capital invested, which I think is the right metric for this in this instance. It's not a matter of how much of the sunlight you convert into energy. It's how much energy you can get out for the investment in the equipment. And a catalytic cracking of water has got so few parts and no moving parts that it's got to be, I think, a very cost-effective way of accessing energy. But also there are other solutions, the biomass and algae, you name it. There's lots and lots of things that have been worked on.
Just ask on that. I mean, Boris Johnson has suggested hydrogen should be used for domestic heating. I mean, is that a good use of hydrogen? My understanding was it's a very small molecule and will therefore leak in domestic piping. So you've got to replace the infrastructure before you can use hydrogen in houses.
It wouldn't be most of the gas network has been upgraded with hydrogen in mind. There are some pipes that need upgrading still, but it can be done without digging it up. It can be lined. The conversion of boilers is not difficult. I do believe hydrogen has a key role to play, and it's a logical end game that we have two grids, one running electricity and one running hydrogen. They're the most complementary energy vectors we can employ. And our grid was, after all, 60% hydrogen until the mid-60s, when we were running on town gas. It was a very nasty mix, but it was mostly hydrogen. And but I don't believe actually in hydrogen as the base load for all our electricity, all our heating, unless we find a lot of non-electrical sources of hydrogen. Because if you've got electricity, you are better off heating electrically with a heat pump than electrolyzing and generating hydrogen. But that's not 100% of the answer. There's definitely going to be some hydrogen that is worth using for heating and some locations where it makes more sense. But none of these things are ever a silver bullet single solution. We're always keen to find them, but it's always more energy efficient and capital efficient to find hybrid solutions where you mix and match. The more different sources we can integrate requires more thinking, but the more efficiently the better solution we'll have at the end of the day. People don't like thinking.
Yeah, it's wonderful that you've thought this through in such detail, and it's wonderful that the message is multiplicity of sources is the answer. Well, thank you very much indeed, Hugo. That's been really inspiring, and we're very grateful to your talk tonight. Thank you.
Thank you.